Start. Yeah. Whenever you're ready.
Okay. Ever since mankind's onset, we have been preoccupied with the bettering ourselves and our species, and this has led us to finding many new innovations of different things to help us become stronger, faster, and smarter. One of these is the repurposing of creatine through supplementations. Creatine is a molecule made of amino acids, and the body converts it to phosphocreatine, which helps increase ATP production in the cells, which is an increase of energy, which helps increase and perfect the body's performance. And this happens through a couple of different ways. So first of all, if the body has more energy, it's able to do more work when doing sets and reps, so the muscles get stronger faster. But creatine also helps with an increase of satellite cell signaling, which is cell-to-cell communication within muscle cells, which leads to an increase in muscle repair after a workout and creating new muscles. And then thirdly, creatine also helps with an increase of anabolic or muscle building hormones within the body, such as insulin growth factor 1, which all help increase the body's strength, which is why this is used. An important distinction to make with creatine is that there's both natural and supplemental creatine. So natural creatine is made in the body's liver, kidneys, and pancreas. It's about 1 gram per day, and creatine can also be gotten through a diet, typically through red meat and seafood. Conversely, supplemental creatine is made synthetically in a lab as a powder, which is then typically mixed with a liquid like Gatorade or water, and then you drink it. And because of natural creatine, supplemental creatine is very easy to get. It is legal to buy and sell, and it is allowed in professional sporting events because it's made in the body, so technically they can't say it's illegal. So because of the natural element to creatine, it is not technically classified as an anabolic steroid. It is just a supplement. So 95% of the body's creatine is stored in the muscles. However, 5% does go to the brain. And some research has been done on some potential benefits of this, especially when it comes to the declining brain. These include an increase in short-term memory, an increase in intelligence and reasoning, lasting longer through someone's life, increased motor performance, and a decrease in neuronal atrophy, which is the breakdown of neurons in the brain, so this happens slower with more creatine use. But despite the amount of studies that have been done on the aging brain, not many studies have been done on the developing brain, which is very important because it is very much still being used. In a study done by Labatz and Smith, it was shown that 44% of athletes in grades 11 and 12 reported using creatine, but creatine use was reported in every grade starting in grade 6, and this is very similar to collegiate levels, so 48% of male D1 athletes use creatine. And this is significant because the brain stops developing at 25. So all of the high school athletes and the vast majority of collegiate athletes are all putting this chemical into their body to help their muscles, and we aren't entirely sure what it could be doing to their brain while that's developing. And this is definitely not slowing down. Like, I personally have friends and classmates I know who use creatine, which is a reason why I wanted to look into this topic. So, not many studies have been done looking into creatine's effects on the developing brain, but a few have. We have one from Souza and the rest of the group there, and one from Iqbal. Souza's study was primarily a renal and hepatic study, but because of the knowledge that something could be happening to the brain of the mice or the rats in the study, it was also observed, and they used a 40-day creatine exposure cycle. And through this study, they concluded that there wasn't a significant impact on creatine use in the brain. However, in the second study, this was specifically a neurological study, and it used younger mice with a longer creatine exposure, and they actually found that creatine benefited the mice over the course of the study and said that it should be potentially used more to try to help with some diseases that present itself. But one way in which my research that I wanted to do is different than these two studies is by the use of zebrafish. So zebrafish have an extensive research history dating back to 1951, and in recent times, over 100 studies are published annually with zebrafish as the primary research subject. And this is for several reasons and characteristics that the fish have. The first is that they're actually very similar. Well, not very, they actually have some good similarities. Zebrafish have a fully sequenced genome, which is 70% similar to the human genome, but 84% of human genes involved in disease have a direct zebrafish counterpart, which is really good that we know that. And then the secondary reason that they are similar to humans is that zebrafish also have organ systems, so you can look at effects on a specific system and systems overall, the same way that would happen in humans. Another reason for this is that zebrafish are very easy to breed and to study. Adult zebrafish can breed about every 10 days or so, and they release about 100 to 150 embryos on average, so you get a lot of bang for your buck with that one. And then the zebrafish embryos are actually clear for about the first 48 hours of life, so it is very, very easy to see in there and watch the development and see what's going on. And third reason why zebrafish are so widely used is because they're very easy to keep and store. Zebrafish are 2 to 4 centimeters, so only about that big, so they're very cheap, and labs of all levels are able to use them. Which all of this together leads to my question of what are the effects of creatine on the cognitive development and behavior of zebrafish embryos? That was what I set out this project looking to answer. So the method that I used to try to answer this question used a creatine dilution for the water of the fish that was 1.25 grams per liter. I wanted to breed the fish in this creatine water and then watch how the embryos developed. So for that, I set up a breeding tank. Here's a picture of it. It's a clear plastic tank, and then we have some netting in the middle, which when this is full, that separates the tank into 2 layers, and then it's pleated up and a lid is placed, and then it's clipped together so the fish can't escape on us. So the fish get put in there, they get put on the top layer of the tank, and then once they breed, the embryos fall below the netting and the fish don't have access to them afterward. And then this entire setup with the tank and the box was covered with a larger cardboard box to begin the light cycle, because zebrafish don't use seasonal indicators to breed. It's a light-dark cycle, so they're kept in the dark for about 10 hours, and then once they're exposed to the light, they start to breed. Which I've hypothesized that creatine would probably harm, there was a chance, or would probably benefit, potentially harm, but definitely impact the embryos that I got. But my results were something very much unlike I was expecting, in that across 5 trials, I did not get any embryos at all, which is very significant that it didn't happen, because all the times we were in the control, we were able to get between 50 and 150 embryos consistently. So creatine addition was the only thing that changed. Which then brings us to the big question of, well, why do we think this is? Primarily, my first guess was that the creatine exposure time for the fish wasn't high enough, so there was a weird chemical in the tank that they weren't used to, and they wouldn't breed because it made them uncomfortable. So I set out with another experiment to try to see if this reason was the cause that they didn't breed. I would consistently keep the fish in a tank with the creatine dilution, 1.25 grams per liter, and then they would be used to it, and then they could breed like normal. But this set out some problems, because we couldn't put in the regular filter that we would normally have on our fish, because it would take the creatine out of the water. So we used an air stone to cycle the oxygen through the tank like we needed. And then I decided to put some aquarium gravel in the bottom because bacteria live in the aquarium gravel and they would eat some of the unwanted waste. And we thought we were good to go and that there weren't going to be any other options or any other things that went wrong. Which brings us to some unfortunate results that ended up happening. So after the fish were in the tank for about a week, they all died overnight, and we think this is due to a chemical reaction happening with the nitrogen waste buildup in the tank. We anticipated the aquarium gravel bacteria to take out more of that than I think they actually did. And that was just kind of it. And after this point is when I stopped doing more of the physical experimenting because I didn't want to kill a bunch more fish. But even though that happened, and that is very sad, we do guess that this was not related to creatine and that it was more a fish living in a tank without a filter kind of problem. So that was kind of a dead end for me. But I did go back and look at one other potential reason why the original experiment did not work, and that is the pH. So creatine, with its chemical structure, is a weak acid, so it makes the pH of things slightly more acidic. But in testing the water, the creatine water pH was about a 5.7, and our tanks are kept at about a 6. So it really didn't think should be significant enough to really affect the fish's breeding, but until we do an experiment testing specifically for the pH, we can't technically rule that out. And then the third potential reason why would be the creatine ultimately, was that something in the creatine made it so that the fish didn't breed. But obviously with these two questions still left unanswered, we cannot yet conclude that. Which then brings me to my further research. If I could do this again, what would I do? First of all, the thing I would want to look into would be keeping more of a long-term tank like I tried to do in the second experiment. Obviously, in an ideal world, we could have both a filter to manage fish waste that wouldn't take out creatine. I'm not sure if such a thing exists, but if I could do this again, I would try to build one of those potentially. Yes, just so they could keep the constant creatine dilution in there. And then I would constantly be monitoring the things that could have potentially impacted the experiment, like the nitrogen level in the tank. Obviously, keep the fish's well-being up. We would want to make sure that they had enough oxygen and carbon dioxide wasn't getting too high, and then also monitoring the pH to look at that second potential question as well. And then I believe that this experiment would produce highly significant results, especially when combined with the research I have done. So if successfully embryos are able to be produced through the second experiment, great, I can look at my original question, but if not, the fact that the fish would not be breeding at all with creatine, I think is significant and would deserve a much closer look. Okay, thank you.
How did you touched on this a little bit, but how did your initial exploration of the scholarly conversation, in other words, the background reading that you'd done, lead you to your final research question?
Yes, so the research that I found when looking at the developing mind, there really wasn't a lot of it, and the ones that I did find all used like rats or mice and not anything with zebrafish. And I think zebrafish can draw some really nice parallels to humans, and especially because we can see the development of their embryos as time goes on. I think that would have added a really insightful, new layer to things. So the lack of zebrafish, I think, would be my answer.
Okay, so what are some real world, let's say you had gotten, the results that you had expected, that everything had worked out. What are real world implications or consequences that are related to your findings?
Well, I think there's a lot of potential for real world findings of this question because so many kids with developing minds still are using creatine for the muscular physical benefits. And I think some potential impact of that would be, well, if it came back and the fish were fine, or if they were like better cognitively than control fish, I think it would be a good idea to try to maybe promote that to kids, especially in their like younger time if the kid is like developmentally challenged or something like that. But then obviously if the reverse is true and something really not good ended up happening, I think it would be very worthwhile to pump the brakes and really try to show like the young kids using it that, hey, this isn't okay and you could be doing serious harm to your body if
Okay.
you keep using it.
Thank you. Think back to your initial curiosity that sparked your inquiry. What other curiosities do you have now, and how has this process prepared you to explore them?
Well, I think this process has really shown me how to like research and create a good question and constantly be like rewriting that and trying to make it the most like specific and like specialized type of thing to really get good results. And also I think this project has really made me adaptable, especially with the lack of original results and then trying to make a second experiment and all of that. So I think those skills I've learned have been really useful. I would love to be able to run the second experiment again, and I still have a curiosity here that I kind of itching to get at. And then taking like a left turn completely, I'm also super interested in like other impacts of like what happens on the mind. So like being a varsity athlete and like how that affects your confidence as opposed to like kids who aren't involved in sports and things like that, I think would also be really cool to look into.
Okay, thank you. Another huge round of applause. I'll add a